Let us look at the installation requirements. Go to the MediaSoup website, go to documentation, version 3 documentation. Under MediaSoup, look at installation. If you don't have these requirements, MediaSoup will fail to build. You'll face a lot of problems. You will need Node, Python, Mac, and so on. And if you're on Windows, you will need Node, Python, and you have to have Visual Studio at least 2015 and follow these instructions. In this tutorial, I'm going to be running the application on Ubuntu, and I will make sure that I install all these requirements. And the Ubuntu will be running within a container, a Docker container. Let's go ahead and set up our environment. I'm now going to create a Docker file to build our Ubuntu image. We first pull Ubuntu image from Docker Hub, and we will run an update and then install all the necessary tools needed to build MediaSoup. We then install Node.js, and we also install Watchify globally and use it to transpile client code when changed. Expose port 3000 for our client and the rest for MediaSoup. We then go ahead and build our image using this Docker file. This will take some time, so be patient. Let's confirm the image has been created. And indeed it has. Let us now create the Docker Compose file for creating our Ubuntu container. If you have worked with containers before, this should be pretty straightforward. Let us first check if we have any containers running, and then run Docker Compose to create and run our container. Let's check again. Now we have our container running based on the Ubuntu image we built and available in our local Docker registry, and also the ports are correctly mapped. Now with Docker extension installed, go to Docker tab. Locate the Ubuntu container and attach Visual Studio Code. We will now be working directly inside the Ubuntu environment. I'm creating a folder for this project. I call it example1. Run npm init to generate our package.json. We will use it to install packages for both our server and client. I'm setting type equals to module so that we can use import instead of require. Let us now install all the packages that we will need for our tutorial. Let us now install MediaSoup. This will take quite a while, so be patient. In my case, it took 13 minutes. We also install MediaSoup client, as well as Nodemon to monitor server code changes. Let us now create a file app.js for our server code. My assumption here is that you already know the basics of working with Node.js and creating Express Server, as well as using socket.io. Let us test our simple Express Server. Notice that we get a response using HTTP, but not HTTPS yet. This is because we need to generate key cert files using OpenSSL. We'll generate the files shortly, but for now, let's just go on with the code. Let us now use OpenSSL to generate the cert and key files. Now we get a response with HTTPS. Let's update scripts and let's use NodeMon to monitor our server changes. Let us now set up an Express middleware mounted on /sfu path to serve static files from public folder. The public folder doesn't yet exist, so let's go and create it. Let's test with a simple HTML file. I created two video components and some buttons we are going to use for testing our code. Let's add some styling to our components. Let's also add a script tag for our bundle.js that is produced by Watchify. We get an error because the bundle.js does not yet exist. Let us now create index.js that will be used by Watchify to produce bundle.js. Watchify will watch for changes to our index.js and package everything into bundle.js. Bundle.js is now generated and there are no more errors. Create a new Socket.io server. And I'll use a namespace called MediaSoup for our connection. Now let's add a connection event on peers. We will then emit back a connection success event. Let us now work on the client side. Notice that we use the same namespace as in the server side. Let us now add connection success event and test. Okay, it's good. We have received the socket ID from the server. Here I am adding click events for the buttons on our UI, and I will comment all but one for now. Let's create the method getLocalStream that is called when the button is clicked. getUserMedia returns a promise, either a success or an error. For these we supply two callbacks. Let's create our method streamSuccess as our success callback. Once we get the video track from the stream, we add it to the params object. Let's go ahead and declare params. Let's now go and test our getUserMedia for the local video. Let me refresh the UI, press the button get local video. Okay, so we need to give permission to this website and then refresh again and get local video. And now we have the video display on the left. So let's go ahead and implement the rest of the functionality. Let's now continue with our code. Oh, by the way, I noticed this error here. Assignment to constant variable is because we declared this to be constant and we are assigning it down here. So let's change it to let instead of constant. Now the error should disappear if we refresh and get local video. Yep, so that's good. As we have seen in the MediaSoup architecture that we first need to create a worker. Let's just revisit that diagram. You can see here, we first need to create a worker before we can create a router or a transport. So let's go ahead and start with the worker. Let's jump to our server code, app.js, and let's declare a worker variable. We create a method that we're going to call to create a worker. And if you remember, we had mapped between ports 2000 and 2020. So we're going to define those as the minimum and maximum RTC ports. Let's log out the worker PID and let's get notified when the worker has died. Now let's return the worker and then let's call our method create worker soon after. Okay, so we're getting an error because we have not imported MediaSoup. Let's scroll up and import MediaSoup. We can use routers to represent our rooms. Let's declare one router for this tutorial. Let's create a router the moment a client is connected. Actually, let me move this down. And then let's create the router and specify the media codec. So let's do that here. There seem to be some errors, so let's go ahead and fix them. Let's fix the typo on MIME type. Let's make sure we get notified when a client disconnects. Now we notice from the diagram here that after the router, we need to create the WebRTC transport. But before we can create the WebRTC transport, we need to create a device. So what's a device when it comes to the client, the MediaSoup client? Let's go and look at the documentation. So a device represents an endpoint that connects to a MediaSoup router to send and or receive media. This is the entry point for JavaScript client-side application. Let's go ahead and create the device. Let's jump to the client code and declare a variable called device. But first, let's require MediaSoup client. Let's go ahead and create a method to create the device. Let's go down. Let's have a quick look at the documentation on device.load. Load method of the device loads the device with the RTP capabilities of the MediaSoup router. This is how the device knows about the allowed media codecs and other settings. This simply means we need to get the RTP capabilities from the router on the server. Let us now jump back and continue with our code. Let's scroll down and uncomment the button event for loading a device. and then create a function called getRTP_capabilities for the button click. We then emit a request to the server for the RTP capabilities and expect a response through this callback method. Now let's jump back to the server and add the socket event. Let's jump to the browser, go back to the app. Okay, let's refresh. Now we're going to click the Get RTP Capabilities, and the expectation is that the server side will print the RTP capabilities and also on the client side, because from the client side we are sending a request to the server to return the router RTP capabilities, and the router will send back to the client. Let's click Get RTP Capabilities button. And yes, so we got on the client side router RTP capabilities object, and on the server side, as you can see, the capabilities are printed out. Okay, so now we've received on the client side. Rename this to data to avoid name conflicts and assign the value to a local variable. And don't forget to declare it. So we have the next button is create device. So let's go ahead and uncomment this out and test by pressing the create device. Let's go back here, test, get RTP capabilities and create device. Okay, so when we create device, we can see the RTP capabilities printed out. Okay, as we have seen in the design, after the router, we need to create the WebRTC transport. So first we have to create the producer transport. Let's keep in mind that we will need two transports. One, the producer transport, and the other one is the consumer transport. So let's go ahead and create a method we're going to call when we press the create send transport button, and we are going to emit a create WebRTC transport event to our server, and we are going to identify this is a sender transport, and we're going to pass in a callback where we expect some parameters. Okay, so let's go ahead and edit here. So we receive the sender and a callback. If it is a sender, then we need to create a producer transport. Else, it will be a consumer transport. But now we haven't created the create WebRTC transport method. So let's go ahead and create it. We first need to define the options. And then we return the transport so that it can be assigned to the producer transport. But we need to define the producer transport, declare it rather. So let's do it up here. Now, because a bit later we're going to need the consumer transport, let's just go ahead and declare it in advance. And as we have seen, we will use the same method to create the consumer transport. Okay, let's just make sure the code is okay over here. Let's go ahead and test and see that we are actually receiving the parameters from the server side. Okay, there is a typo here. Should be emit. Let's go test again. Refresh. Get RTP capabilities. Create device. Create send transport. Okay, now transport is not defined. So we get the sender request is true. We get the transport ID, but it seems okay. There's spelling mistake, so there is a typo there. Should be okay now. Okay, let's go back, refresh, get RTP capabilities, create device, and create transport. Now you see that we received the parameters from the server side. Okay. So let's move on to code and create now the producer transport on the client side. We create a send transport and pass in the parameters we receive from the server. Let's go ahead and declare the producer transport because it doesn't exist yet. Now just a quick recap. If you look at the communication between client and server for the producer, we notice that for sending media, a WebRTC transport must be first created in the media soup router. We did this. We requested the router to create the WebRTC transport. We called it producer transport. And then we do the same on the client side application, which we call the device create send transport. This is what we did here. Okay. And then the client application must subscribe to the connect and produce events in the local transport. So we've done the connect. Let's go ahead and do the subscription to the produce event. So we go down here. We get parameters. And we also pass in a callback from the server where we get the ID of the producer transport. And here we use the callback to send the ID. Now we need to go back to the server and create the transport connect events and transport produce events. Okay. Let's go back to the documentation for the producing transport, and we see once the send transport is created, the client-side application can produce multiple audio and video tracks on it. So as we have seen, the application obtains a track from the get user media. Then in order for our transport to emit the connect and produce events, we need to call the transport.produce in the local send transport. So basically for this event to be triggered and this event to be triggered, we need to call the produce on the producer transport and return a producer on the local side. So let's go ahead and add that event, which will be handled by this button down here, which we call connect send transport. Let's go ahead and add it down here. We pass in params. So we need to define what params is. So let's go back up to the declaration of params here, and let's define what params is. You can find this in the documentation. Let's also declare the producer. Let's add the producer events. So when we click this button, connect send transport, it will call this method and call the producer transport.produce and pass in the parameters that we defined above. And once this is done, as we've seen in the documentation, when we call the produce, transport will emit connect if it's the first time, and it will also call produce, so the application will transmit event parameters to the server and will create a producer instance in the server side. And then finally, on the server side, we'll call transport.produce and resolve with a producer instance in the client side. So when we do produce here, these events will be triggered. So first we'll call connect, and then connect, we will emit transport connect back to the server. We don't expect anything to come back from the server side. So let's go and see the transport connect on the server side. We haven't created the event, so let's go ahead and create it. Let's print the parameters. Actually, we are not sending transport ID, so let's just remove this here. It's called connect on the producer transport and pass in the DTLS parameters. Yeah, we don't need callback as well. We're not sending any callback. We're just passing in the DTLS parameters. If we look back at the transport, we really don't need to send the transport ID. We just need to send the DTLS parameters only. And the callback is just the callback that we received when this connect event was triggered. So we just need to call it so that we inform the producer transport that the parameters were transmitted back to the server. After calling the connect and passing these parameters on the client side, the produce event will be triggered, as we have seen in the documentation here. So let's go ahead and add this event on the server side, just like the connect. Let's see what we're sending from the client side. We don't need to send the transport ID, but we're sending kind per RTP parameters and app data, although we will not make use of the app data. And we're also sending a callback, which is this. So we call here callback. And after doing this, we need to call the callback and send back producer ID. Okay, so when this happens, the callback here will send to the producer transport the ID of the producer. So here we say tell the transport that parameters were transmitted and provide it with the server-side producer ID. Remember that by this time, when we call this producer transport.produce, params will already have a video track in it, and this happened at the time we got the stream, in which case we appended the video track to the params object. So params will have the encoding information, codec information, as well as the track. So let's go ahead and test. Let's refresh. Oh, and don't forget to declare the producer. Well, we have already done that. Should be producer on the server side. Fresh, get local video, get RTP capabilities, create device, create send transport, and then connect send transport and produce. So everything seems to be working fine, as we can see here. Okay, so now let's go and implement the consumer part of the application. So we now need to implement the create receive transport, which is basically the consumer. Let's start by uncommenting the button event, and we're going to call this method. So let's go down here and create it. This time we are going to set sender as false because we are calling the same event on the server side as the send transport, and as before include a callback which receives the parameters. Now notice that we've already created this event call on the server side. It's up here, and we are passing in the sender. Now this time the sender is false, so it's going to create a consumer transport. And we've already declared the variable consumer transport. We definitely have to declare a variable consumer. Let's make sure the client transpiles correctly. Let's go ahead and test this part of the receive transport. Refresh. So for the producer, we did local video, get RTP capabilities, create device, create send transport, and connect send transport and produce. Now for the consumer, we are just going to get RTP capabilities, create device, and then create receive transport to test what we've just implemented. Get RTP capability works without any change. Create device, the same thing, and then create receive transport. Yeah, we get the transport ID. This time the sender request is false, and here we get the params from the server. Now let's go ahead and implement the connect, receive, transport, and consume. Pretty much similar to the send transport. Oh, we haven't really finished the create, receive, transport. So let's go and finish that first. Go back to the client. So we then need to create the consumer transport. Okay, now we need to declare the consumer transport. And we also have to declare the consumer. Just like what we did for the producer, we need to implement the connect event. Signal the DTLS parameters to the server side transport. Tell the transport that parameters were transmitted back to the server. We need to go back to the server and implement this event. Actually, we don't need to send the transport ID, so I'm just going to comment that out. And let's go back to the app.js. And then we call the consumer transport on the server side to connect. I'm sorry, we have to move this inside the connection. So now we have completed the create, receive, transport functionality. We can go ahead and test it. So get RTP capabilities, create device, create, receive, transport. Okay, so we got the ID and we get the parameters, and everything still works as expected. So now let's go and do the connect, receive, transport, and consume. Let's go ahead and uncomment this out and create the method for the receive transport. And then we pass in a callback. Once we have the track, we can set it to remote video SRC objects. And since we emitted a call to consume, let's go back to the server side and create that event. Remember, the callback is this, where we get the params. If we can consume, we create a consumer. And we make sure the stream is paused, because they recommend that when you consume, they say here, as explained in the transport.consume documentation, it is strongly recommended to create the server-side consumer with paused equals to true and resume it once created in the remote endpoint. So that's the reason why we are specifying paused equals to true. But before we go back to the client, and because we started the consumer with paused equal, we will need to resume the playback. So let's go and create another event. We are going to call this event from the client side. So let's go back to the client. Let's go ahead and emit an event called consumer resume. And we are now ready to test our application. Before we test, I need to fix this. Make sure it's an object, because we are calling the params using its name in the client side. Otherwise, you're going to get an error. So let's go ahead and test. Make sure we are using 127.0.0.1. Have to give permission. So when you go to get local video, you'll notice this here, which needs permission. Refresh and try again. This time you get a video, get RTP capabilities, create device, create send transport, and connect send transport. So up to here, we've created the producer transport and producer. Now we need to create the consumer, but we can use the same peer, the same client as the consumer of this video. So let's go ahead and click create receive transport and then connect and consume. But we notice that nothing happens. So this probably has to do with the listen IP address. We had put on the server side 127. Now, because I'm running within the Docker container, I think this has to be 0.0.0.0, and then we say the announced IP is 127.0.0.1. So the announced IP address here would be our host machine and not the container's IP address. So let's go ahead and test this. Refresh, get local video, get RTP capabilities, create device, send transport, connect and produce, and then create receive transport, then connect and receive transport and consume. Let's try that. And we have our video sent to the MediaSoup server and back as a consumer. Now let's try with two browsers and see what happens. So let's make this the producer. We have seen this before. I am now just going through the producer steps very quickly. Now for the consumer, get the RTP capabilities, we need to create the device, and then we do the create receive transport and connect the receive transport and consume this media. And there we go. So we've managed to send media as a producer from this tab and receive as a consumer on this other tab. And that's it for now. Thank you very much for watching.